back, and now we are going to use the Kirchhoff's laws to calculate the currents. We have here this node. We have drawn the original delta. So at this node we can say that I6 prime is equal to I5 plus I4. Okay, the other node here, we can say that I7 plus I6 is equal to I5. At this node, or this node, we can say that I7 plus I8 is equal to I10. At this node we have I9 plus I10 is equal to I6 prime. And we are left now with, we can say as well, okay, let's calculate first I5. If we calculate I5, we can calculate I4, because I6 prime we know it. I5 we can calculate with the drop in this resistor phi, or VR5 over R5 will give us the current I5. VR5 is the drop plus this drop. VR5 is VR6 prime plus VR4 prime over R5. And this is R6 prime times I6 prime plus R4 prime times R4 prime over R5, which is R5, where is it? R5 is 6 over 6. So we can calculate. This is 3.6 times 0.923 plus 1.5 times 0.4615 over 6. This will give us a current of 669.175 milliamps. So I5 is equal to 669.175 milliamps. Knowing I5, we can calculate I4 with this equation. I4 is equal to I6 prime minus I5, and this is I6 prime 0.923 minus 6, or 0.669. So I4 is equal to 253.825 milliamp. I write down I4, this is 253.825. We can calculate now I6 in this node. We have I6 is equal to I5, which we have calculated, minus E7. I5 we have 669.175 minus I7, which is equal to I4 prime. I4 prime, where did I write it down? Haven't write it down. I4 prime, it's equal to I5 prime. So it's minus 461.5 milliamp, and this is 207.675 milliamp. This is I6, 207.675 milliamps. Okay, now we are left the other side. We can calculate here, we can calculate the drop here. I10 is equal to VR10 over R10. VR10 are the drops in this resistances are 8 prime times I6 prime plus R9 prime times I4 prime. The drop in this is the current of flow, and this is the current that flows here over R10, and this is 1.5 times 0.4615 plus 1 times 0.923 over R10. R10 is 3, so I10 is equal to 538.416 milliamp. I write I10 is equal to 538.416 milliamp, and from this we can calculate I8. I8 plus I4 prime is equal to I10. I8 is equal to I10 minus I4 prime. I10 we have calculated 538.416 minus 4 prime, which is equal to I5 prime 461.5. So I8 is equal to the difference, and let's write it down. 538.416 minus 461.5. This will give us 76.916 milliamp. We are left with I9 now to calculate. I9 plus I10 is equal to I6 prime. I9 is equal to I6 prime minus I10. I6 prime is equal to 461.5 minus I10. Well. I9 is I6 prime minus I10. I6 prime is equal to 400. I10 is 538. 538. I8 is 176, that's right. Okay. We are left with this. There is a problem here. I6 prime. Oh, I6 prime is I6 prime. We have it's 909. Why did I? I6 prime is this one. What is this? This is R4 prime. That's what the problem is. Okay, I6 prime is here. So now everything is come back to normal. 923 minus, because I thought that the result is negative, which is a little bit not fair. Okay. So it means that I9 is, now everything is okay. Minus 538.4, and the current is 384.6 milliamps. We have calculated all the currents in the branches of the original circuit, which is here. It looks a little bit complicated, but we managed to calculate all the currents by doing the delta star transformation and by using the current divider method. And that's it, and thank you very much.